Hello learners, today in this video we are going to learn 8th standard science chapter number 5 inside the atom. We have learned about atomic structure and well familiar with atomic number and mass number. So in this session we will focus on the topic valency and electronic configuration. Before we get started, let's take a look at the agenda. In this session, the first module is valency, where we will acquaint ourselves with meaning of valence shell and valence electrons, followed by next module relation between valency and electronic configuration. Lastly, we will move towards the term isotopes, where we will see its meaning with examples and uses of isotopes. In this session, we will get familiar with vocabulary words like valence electrons, inert gases, isotopes and radioactive element, etc. Let's begin with first module, that is valency. First, we will get familiar with some terms valence shell and valence electrons. We have already learned that valency means the number of chemical bonds formed by an atom. The concepts regarding valency of an element, chemical bonds in compounds get clarified from the electronic configuration. Atom forms chemical bonds by using electron of its outermost shell. Valency of an atom is determined by the configuration of its outermost shell. Therefore, the outermost shell is called valence shell. Also, the electrons in the outermost shell are called valence electrons. It can be seen that the valency of an atom is related to the number of valence electrons in that atom. Let's consider example of helium and neon. Helium atom contains 2 electrons which are accommodated in the first shell K. Helium has 1 K shell that contains electron, and the same is also the outermost shell. The electron capacity of K shell is 2. This indicates that the outermost shell of helium is completely filled. It is said that helium has an electron duplet. The electronic configuration of the inert gas neon contains 2 shells, K shell and L shell. L is the valence shell of neon. The electron capacity of L shell is 8. That means the valence shell of neon is completely filled. It is said that neon has an electron octet. The electronic configuration of elements other than inert gases show that they do not have electron octet or their electron octet are incomplete. So, inert gases are chemically inert. Atoms of both these gaseous elements do not combine with any other atom. These elements are chemically inert. It means that their valency is 0. Why elements other than inert gases have tendency to combine with other atoms? Atoms of all the elements except inert gases have tendency to combine with other atoms, meaning that they have a non-zero valency. To get answer of this question, let's see example of hydrogen and chlorine atom. Hydrogen atom has atomic number 1 and its electronic configuration is 1. that is number of electrons in outermost shell is 1. As its duplet is incomplete, its valency is 1. While in case of chlorine atom, atomic number 17, its electronic configuration is 287, that is number of electrons in outermost shell is 7. So its octets is incomplete. So its valency is 1. So let's get acquainted with rules. First rule, valency of an element is same as the number of its valence electrons if this number is 4 or less than 4. For example, in case of carbon, its valency is 4, and for magnesium, its valency is 2. Second rule, on the other hand, when an element has 4 or more valence electrons, the number of electrons by which the octet is short of completion is the valency of that element. For example, in case of chlorine, its valency is 8 minus 7 is equal to 1. Here we will get acquainted with examples to find out valency of element. So let's consider the example of carbon. Carbon has atomic number 6 and its electronic configuration is 2, 4. That is, number of electrons in outermost shell is 4. So its octet is incomplete. So its valency is 4. By losing 4 electrons, carbon completes its duplet. While in case of chlorine atom, atomic number 17, its electronic configuration is 2, 8, 7. That is, number of electrons in outermost shell is 7. So its octet is incomplete. So its valency is 1, because it is easy to chlorine to accept 1 electron rather than lose 7 electrons. By accepting 1 electron, its octet get complete. While in case of magnesium atom, atomic number 12, its electronic configuration is 2, 8, 2. That is, number of electrons in outermost shell is 2. So its octet is incomplete and its valency is 2, because it is easy to magnesium to lose 2 electrons rather than accepting 6 electrons. After losing 2 electrons, magnesium completes its octet. Now let's begin with our next module, that is isotopes. All isotopes of a given element have the same number of protons but different numbers of neutrons in each atom. Examples are isotope of carbon, isotope of hydrogen, etc. Let's get detailed information about isotope of hydrogen atom. Hydrogen atom has 3 isotopes, namely hydrogen, deuterium and tritium, where hydrogen atom has atomic number 1 and mass number 1, where deuterium has atomic number 1 and mass number 2, and tritium has atomic number 1 and mass number 3. Here all isotopes of hydrogen has atomic number, that is 1, and different mass number. So they are isotopes of each other. Another example is an isotope of carbon 12 to carbon 13. For example, Carbon 12, carbon 13 and carbon 14 are 3 isotopes of the element carbon with mass numbers 12, 13 and 14 respectively. The atomic number of carbon is 6, which means that every carbon atom has 6 protons, so that the neutron numbers of these isotopes are 6, 7 and 8 respectively. Carbon 12 is a stable isotope, while carbon 14 is a radioactive isotope. Uranium 235 and uranium 238 occur naturally in the earth crust, is also example of isotope of uranium. Let's get acquainted with uses of isotopes. Isotopes of some elements are radioactive. Uranium 235 is used for nuclear fission and production of electricity. Cobalt 60 are used in the treatment of cancer. Iodine 131 is used in the treatment of goiter, diseases of thyroid gland. Radioactive isotopes are used for food preservation from microbes. Isotope C14 is used for determining the age of archaeological objects. So let's summarize what we have learned in this session. Students got familiar with valency, where we got acquaint ourselves with meaning of valence shell and valence electrons, followed by relation between valency and electronic configuration. Lastly, we learn the term isotope and uses of isotopes. Thank you.